Hey, it's Mrs. Weethy, and we're going to, in this lesson, talk about single replacement reactions. We've already given a description of it, but let's review. In a single replacement reaction, one element is going to replace a similar element in the compound. And that similar element, when we say it's similar, the similarity is in the charge. Now, single replacements also take place in aqueous solutions. That is, a substance that is dissolved in water. The single element can either form positive or negative ions. Let's take a look at what a general equation would look like. Now, you already have this on the handout that I gave you before break, but again, let's review. So let's say you have element A. Element A is going to react with substance Bx. Element A carries a positive charge when it's in a compound. B is positive and X is negative. So what happens is substance A is going to replace substance B. Positive replaces positive. B is going to come out of solution in its elemental form. A is going to form a bond with X, positive with negative, and we have substance AX formed in the chemical reaction. Now similarly, we can take substance X, which will carry a negative charge in a compound, and react that with substance AY. A is positive, Y is negative. Now again, X is negative, so it will replace Y. Y will come out of solution in its elemental form. Substance X will bond with substance A and form new compound AX. Positive ion is always written first, positive then negative. Now, the clincher is the single element has to be more reactive than the element it's replacing. That is, A has to be more reactive than B. X has to be more reactive than Y. And how do you know? To determine the reactivity, you must use what is called the activity series of the elements. I gave a handout in class, but you can also find this handout on my website. So go to the website and look under the reference section. Alright, this is what the activity series looks like. You have a list of elements. At the top are your most reactive, and at the bottom you have your least reactive. So the single element has to be higher up on this list than that it's replacing in the compound. So take a look at this example. You have iron. Iron is going to replace lead. They both carry a positive charge. Iron is higher than lead on the activity series, so this reaction will proceed. Similarly, if we take a look at lead replacing iron, lead is lower than iron on the activity series, so it's not reactive enough to kick iron out of solution. This reaction will not take place, and we'll call that a no reaction. Let's take a look at some examples. We have 4 different types of reactions. The first one is a replacement of a metal by another metal. So let's look at copper. Okay, copper is a solid at room temperature. We are going to react it with silver nitrate, AgNO3. Now, silver nitrate is the aqueous solution. So single replacement reactions take place in aqueous solutions. In the compound, it's generally going to be aqueous. Copper is, let's say in this example, we'll have a positive 1 charge. Silver will be positive 1, nitrate is negative 1. So copper will replace silver. It will kick silver out of solution only if it's higher on the activity series. So take a second to look on your activity series while I'm talking here and see if it's higher. And if you notice, it is. So this reaction is going to proceed. So silver is going to come out of the solution in its elemental form as Ag. It's a solid. And then copper is going to bond with nitrate, +1, -1, and the formula would be CuNO3, and this is an aqueous solution. And the equation is already balanced. Let's take a look at another example. Let's say now we have silver. Silver is a solid. It's going to react with iron 2 chloride, FeCl2. And iron 2 chloride will be our aqueous solution. Now silver, as we know, is +1. Iron is +2. Chlorine is -1. Because iron and silver are both positive, the silver is going to kick the iron out of solution if it's more reactive. So look on your activity series and see if it's higher on the list. And when you do that, you will find that iron is actually lower on the list, so it's less reactive than iron. So this reaction will not proceed, and we'll give this a nice big NR, which is a no reaction. All right, let's take a look at another type of reaction, single replacement reaction. And this is one where metals are going to react with water. Now, you have two groups of metals. You have one that will react with water, cold water, and those metals that will react with hot water or steam. Two different things will happen. Let's take a look at an example. If we have element A, metal A is highly reactive. It's going to react with water. Now we're going to write water instead of H2O as HOH. And when we do that, the element A is positive, hydrogen is positive, hydroxide is negative. Okay? So what happens is A is going to kick the hydrogen out of solution. Hydrogen is going to come out in its elemental form as H2. Metal A is going to bond with hydroxide and form a metal hydroxide. So you would get AOH. Let's take a look at an example. We have sodium. Sodium is in that top list, okay, where it will react with cold water. Sodium carries a +1 charge in a compound. Now, water's never going to be written as HOH. You have to recognize that your metal is that highly reactive metal. You have to envision water as being in the form of HOH, where hydrogen is +1, hydroxide is -1. Sodium is going to kick the hydrogen out of solution. Hydrogen comes out in its elemental form as H2. Sodium, +1, is going to react with hydroxide, it's -1. And our new compound is NaOH, which will be our aqueous solution. Now, water is not aqueous. Water is actually a liquid. Hydrogen is our gas. Balance the equation: 2 in front of sodium hydroxide, 2 in front of water, 2 in front of sodium. Now, for our less reactive metals, those ones are going to react with water in the form of steam. Let's take a look at iron. Okay, iron is a solid. Now this time we're going to write water as H2O, but it's a gas. So it needs to be a little bit, the water in this case needs to be a little bit more reactive. Let's say iron has a +2 charge. In the water, hydrogen is +1, oxygen is -2. The iron is going to kick the hydrogen out of solution. Hydrogen comes out in its elemental form as H2, which is a gas. Iron replaces the hydrogen, bonds with the oxygen. It's +2, -2. So your formula is FeO. Okay, +2, -2, it's going to cancel out. Now this actually happens to be a solid, and we'll talk a little bit more about that when we get into double replacement reactions. Okay, now this reaction is already balanced. Now take a look at the difference. Most reactive metals are going to form a metal hydroxide. Your less reactive metals are going to form a metal oxide, metal with oxygen. So you have to make sure you're looking at your activity series to figure out what it's going to do. How is it going to react? Okay, third type of reaction. We have the replacement of hydrogen in an acid by a metal. Now, hydrogen is on your activity series, but it's further down the list. So let's say we have zinc. This is one of the reactions I did in class. Zinc is a solid. It's going to react with hydrochloric acid, HCl. Acids, by the way, are aqueous solutions. Zinc is positive 2. Hydrogen's positive 1. Chlorine is negative 1. So the zinc is going to kick the hydrogen out if it's higher on the list, and it is. Hydrogen's going to come out in its elemental form as H2, a gas. Zinc is going to form a bond with the chlorine. It's positive 2, negative 1. And the new compound is zinc chloride, ZnCl2, which is an aqueous solution. Balance the reaction by putting a 2 in front of the hydrochloric acid. Now, we can use any kind of acid here. You can use sulfuric, hydronitric, any kind of acid, and you should know how to write your formulas for your acids. All right, last example. Replacement of halogens. Halogens, these are our negative ions. So thus far, the first 3 have to deal with positive ions. This one deals with the negative. Let's say that we have fluorine. Okay, fluorine's correct formula is F2. It's a gas. It's going to react with sodium chloride, which will be our aqueous solution. Now, fluorine in a compound has a negative 1 charge. Sodium is positive 1. Chlorine is negative 1. So you have to be careful with this because there's not as many negative ions that do the replacing. Fluorine, because it's negative, is going to kick chlorine out of solution. Negative is going to kick out negative. Chlorine is going to come out of the solution in its elemental form if fluorine is more reactive, and it is. It's higher up on its activity series. Chlorine comes out as Cl2, which is a gas. Fluorine is going to replace chlorine and bond with sodium. Now, what you have to be careful with is not to carry over the subscript. So do this. Write the symbol for sodium and the symbol for fluorine without subscripts. Check the charge. Sodium's positive 1, fluorine is negative 1. Correct formula is NaF, and that will be your aqueous solution. Balance, 2 in front of sodium fluoride, 2 in front of sodium chloride. Let's take a look at another one. We have bromine, Br2, which is a liquid. It's going to react. Let's use sodium chloride again, NaCl. It's aqueous. Sodium's positive 1, chlorine is negative 1. Bromine is negative 1. So bromine, like fluorine, will kick the chlorine out if it's more reactive. Look on your activity series. It's a separate little box at the bottom of your paper. Bromine actually is lower on the list than chlorine, so therefore this reaction will not take place. It is a no reaction. Alright, I know this video is a little longer than others, but this finishes up the single replacement reactions. So you have a worksheet to do, and your next one will be on double replacement reactions. So this is it for now. So long, Mrs. Wheathy.